This segment is going to talk about symmetry of objects, and we're going to be looking at reflection symmetry or line symmetry, and the other one is called rotational symmetry. We'll start off with regular polygons, and then we'll talk about other shapes as well. So I'm going to start off with a regular polygon known as an equilateral triangle. So there's my original shape, and I'm going to color code the vertices here. And so I've got a black one at the top, a green one on the side, and a blue one on the left-hand side. And talking about reflection symmetry, I need a line of reflection, so I'm going to produce a line here. And I'm just going to try to make it more or less a vertical line. So there's my reflecting line that I'm going to do. And so I'm going to mark this line as my mirror. And then go up here and ask me to reflect. And so as we talked about in our last segment, there's my reflected picture, and I'm just going to change its color so that it changes into a color that's easy for us to distinguish. So there's my original, and here's my reflected color version of my original. So what I'm going to do now is I'm going to see if I can drag my line so that my green one is exactly the same as my original. And there seems to be a line of reflection right there. So I have a line of reflection, or a line of symmetry, running straight up and down through the center of my circle, going through one of my vertices. Now the question is, can I position this line someplace else so I get that same effect happening? Well, it looks like maybe this might be... No, that's not going to work, but it gives me an interesting shape, and it gives me an idea that, well, maybe if I just rotate it around some more, I might be able to get this to work and see how I can go about getting this to work. And if I just slide that whole thing, oh, that looks promising, and I can see that I can get another one if I draw my line through my vertices and again through the center. So I had that one that worked when it was up and down. I also have another one that's going this way. And with a little bit of playing around, I can find that I can get another one if it goes through the center and through the other vertice. And so now we can see that we have a series of different locations for my line of reflection that gives me an original diagram that still looks, my reflected diagram looks exactly the same as my original diagram. So I have lines of reflection here, or I have lines of symmetry, and I have three different positions, one vertical, one going through this way, and one going through this way. So this object has three lines of symmetry, or three lines of reflection. So now I'm going to take our same equilateral triangle, and I'm going to do our angle marking again, and I'm going to tell it to take my diagram, and I want to transform it. I want it to rotate around this center point using this marked angle. And so now as I move this around, my triangle can move around. I'm going to change this color so we can again show what color we're talking about, which one is my original and which one is my new rotated diagram. So my green is going to be my new rotated diagram. So now I'm going to start us off here. We're going to make sure that we start off with no rotation. So my measurement's going to try to get as close to 0 as I can get. So we're basically back to where we start with the green on the top, the black on the top, green on the side, and blue on the left. And as I go around, I notice that it's going to rotate, and I'm going to get it back to my original kind of shape right about here at 120 degrees. As I continue to rotate again around again, I'm going to find it rotates again here at 120 in this direction, and when I rotate it back again, it's going to come back again at the 0 mark. So I've got three different times that it's going to match up: at the 0, at the 120, and at the negative 120. So negative 120 means it's going in this direction. So at 0, 120, and negative 120, I have 3. We talked about we had 3 lines of reflection. I also have three times that I can rotate it. It rotates in 3 different places to come back to my original. So this is called our rotation symmetry. So our triangle had, our equilateral triangle, our regular polygon triangle, had 3 different rotation symmetries. So therefore, we could say that it has an order of rotation of 3. So we had 3 lines of reflection, or 3 lines of symmetry, and we also had 3 places where we could rotate it, or an order of 3 for our rotational symmetry. Let's try a different shape. So now we're going to look at a square, which is a regular polygon of 4 sides that are equal lengths, and we're going to look for our lines of symmetry in an even-shaped object instead of an odd shape like we did on our triangle. So I'm going to make a line of reflection again. So here we have a vertical line for our reflection line, and if I drag it over, I'm going to drag it over so I get something. Well, let's do it the same way we did before, so the computer will show our reflection. So in pink is my regular square, and then this is my image, and if I change where my mirror is, it can change it. So if I slide my mirror across, I can get it duplicating right about there, where it goes again through the center of my object. And we want to make sure that the students recognize, if with a couple of examples, that it goes through the center. So we've got this left-right symmetry now that takes place. What happens if we change our line so that it's horizontal? And if I take my line and I bring it up, I can see again that I've got a line of symmetry through the center going through one of my sides. Okay. So far I've got 2. I've got my vertical line and I've got my horizontal line. Both give me lines of reflection. And so let's see if we can find another one. When we worked with a triangle, it went through the center and halfway through one of the sides, and these ones have gone through halfway through the sides, through their midpoints. But they also went through the vertices, through the corners. So let's see if we can move this so it goes through the corners and see if it gives me reflection. And there it is there. There's my line of reflection going on an angle now. And if I move that across, I can see I get another line of reflection. I duplicate my shape if I change my line of reflection to go on the horizontal here. What about the other way? And here is my line going in the other direction, and if I slide it over, my reflected is exactly the same as my original. So there's another one. So I had a vertical, I had a horizontal, I had a diagonal going up to the right, and I had a diagonal going down to the right. So that gave me 4 lines of reflection, or 4 reflection symmetry lines. If I'm going to do the same thing with my rotations now, I take a look at my diagram, and I want to make a rotation following this angle that I've got down here. So we're going to rotate it, and again we're going to change this to the green color so that we are consistent. So there's my new shape, my reflected shape. And if I started us off at 0 degrees, or as close to 0 as I can with just my hand, there is 1. And if I turn it, there is another one, and I'm at 90 degrees. I rotate it so I'm down here, there's another one, so I'm at 180 degrees. I rotate it again, I'm at negative 90, which is 270 degrees, and I rotate it back up again, and I'm back up here. So I can get it located in the exact same alignment 4 different times in my rotation. So therefore it has a rotational symmetry of 4. And so we've done one with an odd number in a triangle, and we've done one with an even number with a square, and we've noticed that the lines of symmetry are related to the order of rotation, or the lines, or the number of times that my shape would come back to its original shape as I'm working its way around a center point of rotation. So now I've created a parallelogram, a rhombus, and we'll see what's going to happen here. So if I take my reflection line and my original, let's make a reflection for that. And so we've got our original in pink, and again our reflection in green. And I try to move this across to see if we can get something that's the same. So I line it up in the center, but it doesn't really work. Let's try in the horizontal. So here we are in the horizontal, and I bring it down, and that doesn't line up either. Well, let's try that diagonal thing that worked last time. So there we are on the horizontal, on the diagonal, and we bring it across, and that works. So we have one line of symmetry that way. And let's try it in the other diagonal. We drag it across, and yes, that works. So we seem to have two lines of symmetry here, or two lines of reflection. Let's try our rotations. Sorry, I mean our rotations. I'll mark the center as my point that I'm going to rotate around. And so when I have basically no change, they're lined up on top of each other. At 0 degrees, I'm back to where I started. And as I continue to rotate, do we have any place where it meets? Not there. Not there. There's our first one at 180 degrees. And again, we don't get it mixing up and matching until we get back up to here again. So there's two locations, so therefore we have a order of rotation of 2. So even though we had 4 sides, we only had 2 lines of symmetry and 2 orders of symmetry. Let's try a different picture. So let's take a picture like this, a well-known place called the Eiffel Tower. And so I'm going to take my vertical line, and I'm going to bring that across to the middle, or what I think to be looks like the middle. That looks pretty middle-ish to me, with a little bit of variation. And I'm going to put a dot someplace on my diagram. Let's put it right here on the edge of the stairway. I'll mark this as the mirror, and this is my transformation point. And I just reflected this point across the mirror, and it looks like it hits pretty much right on. So let's take a look. If I move this point down over to this portion, it seems to hit. And I drag it all the way up along the side. There it is. And I continue to drag it up and move it in so that it's on the line. Seems to be pretty much centered. So this picture would indicate that it has a line of symmetry down through the center of it and along the archway as well. So we have our line of symmetry down the center. So this picture we could say would be symmetrical. We could say that it's vertically symmetrical, but it certainly isn't horizontally because there's no pointy end down at the bottom. So it has a line of vertical symmetry, or the picture is vertically symmetrical. So in this segment we've talked about symmetry. We've talked about the following terms. We talked about reflection symmetry. It's being reflected on either side of the line. And we've talked about that's also in line symmetry. We have vertical line symmetry. We have horizontal line symmetry. We can also have some diagonal line symmetry as well. We've also talked about rotational symmetry, spinning around a center point. How many times does it go around to have the exact same shape? And then that led to the order of rotational symmetry, the number of times that we get the original shape over and over and over again in one 360-degree rotation. So these are all the terms that we've talked about: reflection of symmetry, line symmetry, rotational symmetry, and order of rotational symmetry.